My name is Jamie Robertson. I'm from Aberdeen. I'm an honorary research fellow at the University of Aberdeen. My long-term research interest has been the association between environment and disease. At least 50% of naturally ventilated buildings are not competent at the ventilation level. And the reasons why it impacts negatively on productivity and health is that with a lack of ventilation, you're more likely to get an accumulation of moisture in a building, of heat in a building with bigger cattle, which means it's a better environment for bacteria and viruses. The value of a smoke bomb test is the visualization of the extremes of either good or bad ventilation. A lack of smoke movement means a lack of fresh air, and conversely, if with young cattle the smoke disappears within seconds, then we've probably got an air speed problem. So we can use it as a double-edged tool, and the visualization is very simple. Okay, when carrying out a smoke bomb test, the first thing is don't bother if there's no animals in the building. The main rules is to grasp the opportunity when wind speeds are low, and therefore we're relying on the natural dynamics of the building to ventilate. That's the best time to do it. But certainly you should use it amongst different stock, and also go with what you probably know already, that one end of the building is maybe more stagnant than another. Well, use two smoke bombs and visualize the difference. Okie doke, simple smoke pellet, cigarette lighter. Some people might comment that you need a bucket of water present in case it goes wrong, but actually there's no flame. Always definitely want to be at animal height. And what we're looking for, you will tend to see the smoke rise because it's a warm smoke. But what we're looking for is either excessive airspeed on the one hand, which would demonstrate there's a draft, but in here there's no draft at all. It's very competent. On the other side of the equation, what we're looking for is the smoke accumulating in the building and not giving us enough ventilation to remove the air. So most of what we're seeing there, you can see there's obviously a little bit of a breeze coming in the sidewall, which is what we want, of course. But because this is a calf house, one thing you will not get is a stack effect. So what we're getting here, this air is being mostly influenced by the wind around it, and on a particularly still day, it would just stay accumulated in this space for more than 40 seconds, which would be my target. A little bit of air movement in this example because the wind's coming over a mild breeze over my shoulder, pushes the smoke down the house. But there's obviously there's no elevated airspeed here. There's nothing here that would upset the cows. Same again, the fact it doesn't appear to move very fast doesn't matter. A building like this, there's a lot of energy in it. What's important is it keeps moving.